Assalamu alaikum everyone. We are starting with Algebra, lecture 15, and this is the second part of graphs. This is the plotting part. Now let's look at this question. The question says, complete the table for y is equals to x square over 2 minus 3x plus 2. First of all, yes, we are doing the plotting, but we should have a pretty good idea that what kind of graph will it look like. The highest power is x square, so therefore it's a quadratic graph. Now, first thing first, we have to fill in these two values of x. So let's fill it up. Grab your calculators and double check the answer with me. So if I plug in the value of -1, so when x is -1, y is equals to -1 square over 2 minus 3 times -1, 3 times -1 plus 2. So this is half, this is 3, this is plus 2. How much is that? 3 plus 2 is 5, 5.5. So this comes out to be 5.5. We will just check the answer also. What about when x is equals to 7? When x is equals to 7, y is equals to 7 square over 2 minus 3 into 7 plus 2. This is 49 over 2, that is 24.5. And this is 21, and this is 2. So 24 plus 2 is 26. 26.5 minus 25, that is also 5.5. Now, what do we observe? We observe symmetry over here, and that is a trademark of a quadratic. That quadratic is symmetrical about the turning point. Now, let's look at the values. Let's just compare them. So now if I compare this 2 with this 2, I see symmetry over here. If I compare this -0.5 with this -0.5, I see a symmetry over here. If I compare this -2 with this -2, I see a symmetry. And then this orange one, that is 2.5. So that is like the turning point. So this 3 is like the turning point. 1 unit on the left, 1 unit on the right. You get the same y value. 2 units on the left, 2 units on the right. You get the same y value. Another thing, 3 units on the left, 3 units on the right. You get the same y value, and the same goes for 4 units on the left, 4 units on the right. So this is the concept of turning point, and we will study it further when we'll be doing completing square method. Right now, our focus is on drawing the graph. So this is the graph that you see over here. Let me just plug in the points over here. Now, since you all have this printout with you ready, so I would stop over here, and either you do it electronically on your tablet, or you do it on your piece of paper with a pencil. Just go ahead, take few minutes, plot the graph, and I want to see the shape of the graph. Till that time, let me just pause the recording. So now what are we doing? We are plotting the points. Let me start with this point, and let me make it a bit thicker. That is 3 and -2.5. So 3 and -2.5. So this goes something like this. That is the point. Double check. This is 1 unit, this is 2 unit, this is 2.5 unit. Perfect. The other point, the pink one, 2 is giving me -2, and 5 and 6 is giving me -2. Actually, 2 and 4, they are giving me -2. So 2 is giving me -2. Hold for a second. And 4 is giving me -2. So just look at the symmetry over here. Then the purple points, 1 and 5, they are giving me -0.5. 1 is giving me -0.5. 5 is giving me -0.5. If I'm not mistaken, yes, it's almost over here. Then we have the green points. That is this one. 0 is giving me 2. 6 is giving me 2. 0 is giving me 2. And 6 is giving me 2. And then we have 5.5, the blue points. So let me just mark it. -1 is giving me 5.5. 7 is giving me 5.5. So this is 5 and 5.5 over here, and 7 is giving me 5.5. This is 4, this is 5, this is like. So now you can see the graph. It's going like this, like this, like this, like this, all the way over here. So that's how the symmetrical graph is drawn. So let me choose this color, pinkish color, and let me just show the graph like this. Okay, so I think, let me just make it a little bit thinner. Okay, it's not very exact. The curvature is good. So I think let me just join it like this. And something like this. And something like this. Not like this. Okay, so that's how the graph is drawn. I mean, you see sudden breaks over there. That is because of that thing that it would snap to other shapes and required to hold snap, whatever that is. So maybe that is the reason, and that's how the graph is drawn. Also, make a habit of highlighting the points. So this is one point, this is the other point, this is the third point, this is the fourth point, fifth, sixth, seventh, eighth, and ninth. So that's how the graph is drawn. Now it says by drawing a tangent, estimate the gradient of the curve at the point x is equals to 1.5. So let me go to x is equals to 1.5. So that is this point over here. And let me draw a line like this. And at this point, I'll be drawing a tangent, a green tangent. This is not green, this is green. Okay, I think that's a very nice tangent. And first of all, always use the value that you got started with. So if I have 1.5, do I have 1.5 over here? No, I don't have 1.5. So I can just read off this value. And if I make it bigger, I think this value is giving me over here something like this, which comes out to be -1, and that is -1.6. So this is -1.6. That's the point that I got. So this is 1.5, comma, -1.6. And let me choose this point that's right over here, which is 0, comma, and if I ignore the thickness, so this is 0.2, 0.4, 0.5, 0, comma, 0.5. So that is what I got. So this is 0, comma, 0.5. And if I calculate the gradient, this is 1.6. So -1.6 minus 0.5 divided by 1.5 minus 0. So this is -2.1 over 1.5. That is -21 over 15. And 3 sevens are 3 fives are. So I think that is -1.4. Is that the answer? So let me just double check. So tangent drawn, tangent lies between these two values, -1.7 to -1.3. Our answer is -1.4. That is perfectly acceptable. These two were the y values. That is the smooth curve for 8 or 9 points correctly plotted. So let me just pause for Azan. So now let's look at the question. So we have done these parts. That is part A, part B, part C. Now let's look at part D. Now the question says, complete these inequalities to describe the range of values of x where y is greater than 0. What does it mean? You look at this graph and you observe that the y values are positive over here. The y values are positive over here. For which values are the y values positive? Now keep in mind this graph that I've drawn, it could be a little bit more slanted like this. So let me make it a bit realistic. So let me erase this and this. And let me grab the same pink color. And let me join it again like this, like this, like this. Okay, it is a bit thicker. I can understand that. Let me make it thinner. So now let's go like this and all the way like this. That's how the graph is drawn. Now let me mark this point over here. Which point is this? So if I look closely, this is 0, this is 1, this is 0 0.5, 0 0.6, 0 0.7, 0 0.8. So to me, it looks like 0 0.8. Over here, again, if I draw the graph more accurately, again using the pink color, so now it's going like this and like this and like this, okay, within the limits of human error. So again, if I choose this color, this I think looks like 5.3 to me. So that is 0 0.8, that is 5.3. So I will say what? If I go to the left of 0 0.8, the y values will be positive. If I go to the right of 5.3, y values would be positive. So the inequality is x is lesser than or equal to 0 0.8, x is greater than or equal to 5.3. Let's go ahead and check this answer. So x is lesser than or equal to 0.6 to 0.9. Our answer is 0.8. That is a perfect answer. Between 5.1 and 5.4, our answer is 5.3. So this is perfectly good. I hope you all are following exactly what we are doing. We solved an inequality based upon graph. So we looked at the region. We talked about the values of y for which y value is positive. Y value positive means above the x-axis. Okay, so let me write it over here. When it says y is greater than or equal to 0, that means the region above x-axis. So if I again give you the idea like this, so that is the curve like this. And these were the two values. One value was negative. Actually, both were positive. This is 0 0.8. This is 5.3. When we go to the right, we would be going up. When we go to the left, we would be going up. So that is exactly what we have solved. Now, another part. It says on the same grid, draw the line 4y plus 3x is equals to 12. Now, how can we draw this line? We can draw this line by saying, let me make x is equals to 0. So therefore, 4y is equals to 12. Y comes out to be 3. So 0, 3 is a point. Similarly, y is equals to 0. Therefore, 3x is equals to 12. X is equals to 4. So 4, 0 is another point. So mark these 2 points, 0, 3, 4, 0 on the grid. 0, 3 is this point. And 4, 0 is this point. And let me draw a line through these 2 points. So let me choose, let me use the blue color over here. So if I use this blue color, no, not exactly, approximately like this. Okay, so this is the line. Let me label it. 4y plus 3x is equals to 12. So 4y plus 3x is equals to 12. That's the line. Now, I have this gut feeling that they would be talking about the points of intersection. So this is one of the point of intersection. That is the other point. So this looks like negative 0.5 to me. And this looks like positive 5 to me. Okay. Now, how have they worded this question? They are saying that the x coordinates of the points of intersection of this line and the curve are the solutions of this equation. Now, first of all, let me give you the shortcut. First of all, if I talk about the shortcut, what is the shortcut? Naturally, they ask this question after making you draw this thing, and you have already drawn the curve. That means this is in context of the curve and this line. So the shortcut says, make the two equations equal to one another, and then I'll make you understand the logic. So if I make them equal to one another, what do I get? What is the equation of the curve? X square over 2 minus 3x plus 2. So this is x square over 2 minus 3x plus 2. That is the equation. And this color, this is the blue line that we have drawn. So what is the blue line? The blue line is, this is 4y is equals to 3x plus 12. Let me just remove this color. Let me write blue over here. So 4y is equals to 12 minus 3x. Therefore, y is 12 minus 3x over 4. This is equal to y. This was equal to y. So therefore, 12 minus 3x over 4. So now I have equated this to one another. Now what I'll do is that I'll multiply both sides by 4. Why? Because I want to get rid of this 4. I want to get rid of this 2. So if I multiply by 4, this is 4 times x square over 2 minus 3x plus 2. And this is 12 minus 3x over 4 multiplied by 4. Now, naturally, the 4's cancel out. And this 4 will multiply with each one of them. So this becomes 2x squared. This becomes 12x. And this becomes 4 2s are 8. All good. And this is 12 minus 3x. Transfer everything to one side. So this is 2x squared minus 12x plus 3x. That is negative 9x. And 8 minus 12, that is negative 4 equals to 0. Now compare it with what they have given. They have given this 2x squared plus ax plus b equals to 0. That means if I compare coefficients, what do I get? I get a is equals to negative 9. I get b is equals to negative 4. Now, first of all, let me make you understand the methodology that I've applied. They have first asked to draw this line. This is the standard form of this equation of a line. I plugged in x is equals to 0. I get the corresponding value of y. I plugged in y is equals to 0. I get the corresponding value of x. I joined these 2 points and I get 2 points of intersection. If they would have asked me the points of intersection, that would be negative 0.5 and 5. Okay. But they are asking me something else. They are asking me that the x coordinates of the points of intersection of this line and the curve. This is the curve, y is equals to something. This is the line, y is equals to something. They are the solution of this equation. So first of all, I'm focusing on the shortcut. Make the two equations equal to one another. This is y equals to something. This is y equals to something. This is y equals to something. I made them equal to one another. I simplified. I get this equation. They are saying the equation is of the form y is equals to 2x squared plus ax plus b is equals to 0. I got this equation. I compared the coefficients. A is the coefficient of x, minus 9 is the coefficient of x. Therefore, a is negative 9. Similarly, b is the constant term. B is negative 4. Now, a is negative 9, b is 4, and that is the 100% correct answer. So all good, all clear. Now the question arises, what is the logic behind it? And that we need to understand. So what is the logic behind that previous question? Why did we equate the equation of the curve? And why did we equate the equation of the line with that? So let me make you understand this thing with a very simple example. Let's say, let me draw a grid first. So I'm drawing a grid over here. And let me draw a line, y is equals to 2x. So this is the line, y is equals to 2x. Let me make it more appropriate. And I'm joining this point with this point and this point. Okay, And let me draw something else, a quadratic curve, a blue curve or a green curve. No, it's not good. Let me draw the curve again. I think this is better. No, let me just remove this line like this. Let me take this curve because it was not intersecting. And now let me draw the line. So the red line that goes like this. Okay. Now, first of all, this line, let me label it y is equals to 2x. So first of all, let me draw the line. This is y is equals to 2x. And the green curve that goes like this, that is y is equals to x squared. How many points of intersection do you see? This is y is equals to 2x. This is y is equals to x squared. This is the y-axis. This is the x-axis. You see 2 points of intersection. And we will find with calculation that the 2 points are 0 and 2. So the solutions are x is equals to 0 and x is equals to 2. This is one thing. Basically, if I make you draw the curve y is equals to x squared, then I make you draw the line. So they are intersecting at 2 points. Now, another approach. If I say make a single equation and find solution of that equation. So I have the equation of the curve, that is the green one. Y is equals to x squared. I have the equation of the red line, which is y is equals to 2x. And they both are equaling y. And if I have x squared is equals to 2x, let me solve this. X squared minus 2x equals to 0. X common, x minus 2 equals to 0. What do I get? X is equals to 0. X is equals to 2. The bottom line of the story is a curve and a line intersecting with one another. This is the same as make a new equation by equating curve and line and equate it to 0. So that will give us the same solution. Do you understand this thoroughly? Just acknowledge it on the WhatsApp. What I'm saying is this. You have the equation of a curve. You have an equation of a line. These two intersecting with one another will give me the same solution if I make them both equal to y. If I take x squared from here, 2x from here, make a new equation, equal it to 0, that will give me the same answer. And for example, if I would have drawn this thing, if I would have drawn this curve over here, do you know how would it look like? So that is the factorized form of a quadratic equation. The curve would be going like this, and it would be intersecting at 2 points. This would be 0, this would be 2. This is the equation of y is equals to x squared minus 2x, which can be written as x minus 2. So this is done graphically. This is one single equation intersecting the x-axis. This is the same equation solved algebraically. And this is two equations intersecting with one another. So that is the logic that is used over here. What it says is this: draw this line. The x coordinate of the point of intersection of this line and the curve are the solution of this single equation equating to 0. So how can we get this equation? we make y the subject in the equation of a line. Y is equals to this thing, x square over 2 minus 3x plus 2. That is the equation of the curve. We equate the line and the curve. We simplify. We get one single equation. This one single equation equating to 0 will give us the same point of intersection in which the line intersects the curve. I hope this is all good, all clear. So now that is the logic that I've taught you. So now again, another question. Let me just get this value from the answer. So this is part A. The first answer is negative 1.6. I'll simply write it over here. So this answer comes out to be negative 1.6. That is based upon calculation. Now there is an x on the outside, and the highest power on the inside is x squared. So x squared into x is x cubed. So now we have these values, and the first thing is just plotting them. So negative 3, first of all, let me look at the x-axis. So each small is square is 0.1. So 10 small squares make 1 unit. Over here, 5 small square makes 2 units. So the scales are different. Negative 3 is giving me negative 5.4. So this is negative 3 is giving me positive 5.4. So this is 4, this is 5, this is positive 5.4. Negative 2 is giving me 0.8. Negative 2 is giving me 0.8. That is the second point. Let me mark it properly. And then negative 1 is giving me negative 0.6. So negative 0.6 is, I think, over here. And then 0 is giving me 0. And then we have 1 is giving me 1.4. So this is 1 and this is 1.4. 2 is giving me 2.4. That is 2.4. And 3 is giving me 1.8. 3 is giving me 1.8. So that is 1. And 1.8 is almost here. Not exactly. Let me mark it correctly. This is 1. This is 1.8. And the last one is 4 is giving me negative 1.6. So negative 1.6 is right over here. So now I will join it. So let me use a green color. And it's going like this, not very exact. It's too much curvature, something like this. Okay, good enough. Okay, so that's the graph of y is equals to x cubed. This cubic graph that's drawn, negative 3 to 4. By drawing a tangent, estimate at the point negative 2, 0.8. So they have given us the x coordinate and the y coordinate. So negative 2, 0.8, that is 1 point. Let me mark this point, negative 2, 0.8, that is this point over here. And we need to draw a tangent. So let me draw a purple tangent over here. Okay, I think let me make it a little bit better. I think this is good enough. And let me mark this point that is over here. So this is how much? This is negative 1, negative 1.5, negative 1.6, negative 1.7, 0. So let me write this thing. This is negative 1.7, 0. So the gradient based upon this, that is 0.8 minus 0 divided by negative 2 minus negative 1.7. That is 0.8 at the top. Negative 2 plus 1.7 is negative 0.3. And this comes out to be 8 over 3, which is approximately how much? 2 whole 1/3, 2/3. 2 whole 2/3 with a negative sign. So this is negative, this is negative. Now let's look at the answer. So this is tangent drawn at this point, and the answer lies between negative 3.1, negative 2.2. This is negative, this is negative. Our answer is negative 2 2/3 in fractions, which is negative 2.6667 and something like this. So it falls into this category, and that is perfect answer. That is perfect. So negative 2.67, you can write this thing in the answer correct to three significant figures. Okay, now this thing is done. Now it says use your graph to solve this equation, this thing, which is almost the same thing as this thing, equals to 10. Now, how should I do that? Now, first of all, look at the equation. The equation is x. There is an x over here. 6 plus 2x minus x squared. 6 plus 2x minus x squared. But what extra thing is there? 5, which is not written over here. So now the strategy is first make the left-hand side equal to equation of curve. How can I make it? I can make it by divide both sides by 5. So this thing was the missing piece. So therefore, x bracket 6 plus 2x minus x squared divided by 5 is equals to 10 over 5. 10 over 5 comes out to be 2. So now this thing is equals to the equation of the curve, which is y is equals to something. And this thing simplifies to 2. So therefore, y is equals to 2. Draw this line. Draw the line, y is equals to 2. So now y is equals to 2. Let me draw it in red color. So now y is equals to 2 is a line that will be passing like this. And let me write over here, this is y equals to 2. Now, how many points of intersection do you see? This is the curve. Let me use another color. So this is the blue intersection. That is another intersection. That is another intersection. So now if I look closely, what do I observe? This value is something like negative 2.45. So let me write over here. This is negative 2.45. Over here, this value is how much? This is negative 1.5, 1.55 approximate. And this is how much? This is 2.5, 2.6, 2.7, approximately 2.7. So negative 2.45, 1.55, 2.7. So negative 2.55. And then we have 45, 1.55. 1.55. Let me just correct this one. 45. And the third one is 2.7. So 2.7. So these are the three solutions of this equation. All good? All clear? Let's double check. So 2.45, 1.55, 2.7. 2.45 lies within this range. 1.55 perfect, 2.7 perfect. So all these answers are all good, all clear. So that's how this particular question is done. Okay, so now let's look at this question. We won't solve the whole question. We will just have a sneak preview of it. What this question says is that the diagram shows some values for y is equals to 1 plus 2 over x given correct to 2 decimal places where appropriate. So these are rounded off values. So for example, if I plug in 8 over here, so y is equals to 1 plus 2 over 8. 2 over 8 is 1/4. Therefore, this is 1.25. That's the value. And then this is a reciprocal graph. So this is 1 plus 2 over x. This is a simple reciprocal graph. And remember, this adjustment that we talked about, the movement up or down, this we will study in sketches, and we will draw this graph. And then it says the line L crosses the graph at such and such. Find the equation of this line. So now it's a nice question. I would like you people to try it out in your homework. So I'm just leaving it for you people to try. Let me go to the next question. The answers are given over here. Another question over here. This is like a cubic equation. And then after you have tried it out, I would definitely share the solutions with you. Then it's the same kind of question like that. And then again, this is like the previous thing. Just have a look. On the grid, draw this line. Write down the x coordinates of the point where the line intersects the graph. These x coordinates are solutions of this equation. So this is a combination of taking this thing, intersecting with this thing, this time writing down the solution as well as the comparing coefficient part. So now you'll be able to do this. This is exactly like the question that we discussed over here. This one. This is exactly like that. Make the two equations equal to one another. So I'm just giving you ideas that you have to work out certain things and you have to be very confident about what you exactly work. But first of all, it all depends on you writing down the questions. Another question, this time, this is a power graph. This is a power or an exponential graph. Remember when we did sketches, we drew something like this, y is equals to a power x if a is positive. And we know that the graph will be something like this. So the graph will look like this. If I plug in the value of x is equals to 0, 4 raised to power of 0 is 1. If I plug in the value of half, 4 raised to power of half, that means square root of 4. This comes out to be 2. So this is 1, this is 2, this is 4, this is 8. This is like a number pattern, and we will study number pattern also. So this is called like a geometric progression in which each term is obtained from the previous one by a multiplication factor of 2. So 1 into 2 is 4, 2 into 2 is 1, into 2 is 2, 2 into 2 is 4, into 2 is 8, into 2 is 16, into 2 is 32, into 2 is 64. So that's how the curve would be going like this. And again, the same kind of questions are being asked over here. This is about completing square method, and this we will study in a separate class. So this weekend, we will have a class in which I would like you people to try out all these questions, and the class will simply be on going over the homework. So make sure your homework is ready. I'll get my homework ready, and then we will go over these questions. Okay? So I'll see you in the next class, and just be careful. This is x cube over here. It's a little bit missing from here. So let me write it over here. So this is another cubic graph that you need to draw. So a lot of questions for you to try it out. Till the next class, take care.